Sample problem 3.4 reads, nitrogen dioxide is a component of urban smog that forms from the gases in car exhausts. How many molecules are in 8.92 grams of nitrogen dioxide? So just as before with any conversion type problem, I'm going to start out by writing down exactly what I know. I know that I have 8.92 grams of nitrogen dioxide. Now, it does not give me the chemical formula here. It's important that you remember those naming rules from Chapter 2, because a lot of times when you get to the exam or on some of these Connect homework problems, they will not tell you the formula. You'll have to be able to write the formula from the name. So please remember those naming rules from Chapter 2. So nitrogen dioxide, this is a covalent compound because those are both nonmetals, right? So I'm going to follow those rules whenever writing the formula. So with no prefix being there, that means I just have one nitrogen. Dioxide, that means I have two oxygens. All right, so that's what I know. Now they're asking for the number of NO2 molecules. So let me write that down. Equals question mark. Remember, anytime they're asking for the number of things, we immediately just go ahead and write down Avogadro's number. 6.022 times 10 to the 23 entities per mole. And now let's analyze this and see what kind of units we have going on. Avogadro's number tells me the number of entities per mole. They're asking for the number of molecules, so I'm definitely going to use Avogadro's number. Now, the information they're giving me is grams. So somehow I have to get from grams to moles so that I can use Avogadro's number. So this is another one of those problems where we're going to have to use multiple conversion factors. And the one that relates grams to moles, if you'll remember, are the units on the periodic table, or the molar mass, right? Because those units on the periodic table are in grams per mole. So let me go ahead and write up my conversion T here. And I've got to figure out the molar mass of nitrogen dioxide. So let's see, the mass of one nitrogen atom is 14.01 grams per mole. The mass of an oxygen atom from the periodic table is 16.00 grams per mole. So if I'm trying to find the molar mass of NO2, that's going to equal 14.01 plus 2 times 16, right? Because I have two oxygen atoms. So let's see, what's that going to equal? 14.01 plus 2 times 16, or 32, right, is 46.01 grams per mole of NO2. So I'm going to use that as my conversion factor. So I have grams in the top of my T, so I need grams in the bottom. And so we just calculated it, right? It's 46.01 grams of NO2 and 1 mole of NO2. Let's check our units here. We've got grams divided by grams. I'm going to be left in moles. And let's see what I get here. 8.92 divided by my 46.01 equals, I got 0.1939 moles of NO2. So I need a little more room to write here. Moles of NO2. And now I'm going to bring that down here and start another T. So 0.1939 moles NO2. Now I can use Avogadro's number, right? Because it'll get me from moles to the number of things, which is what this question's asking for, right? The number of NO2 molecules. And so Avogadro's number tells me that in 1 mole of NO2, there are 6.022 times 10 to the 23 entities, our entities here being NO2 molecules. Okay, so let me extend my T there. All right, let's check our units. I've got moles divided by moles. Those are going to equal 1 and cancel out. So this is going to equal, let's see, Avogadro's number. So 0.01939 times 6.022 times 10 raised to the 23 equals, I got 1 point, oops, got to get my pen here, 1.1 17 times 10 to the 23 NO2, NO2 molecules.